And continuing with our Doppler shift questions, this is probably one of the last Doppler shift questions that we'll do as a video, as it's similar to the other questions in your book. Trying to figure out what fraction of the speed of sound must a source be moving. Wow, I do that a lot. Be moving so that a stationary observer hears a frequency. Well, while we're here, frequency, forgot my N, 4 times greater than the source frequency. I spelled it right that time. So what fraction of the speed of sound must the source be moving so that a stationary observer hears a frequency 4 times greater than the source? One thing you'll notice as I get through this problem is that we do not have a lot of numbers to work with. We don't have a lot of mathematical calculations to do. What we have to do is algebra. It's manipulating the math equation to make it look like what we want, and what we want is a ratio. So this is asking us to figure out what the speed of the source divided by the speed of sound has to be to hear an observed frequency 4 times greater than the source frequency. Okay? Doesn't matter what the air temperature is, doesn't matter what the speed of sound is, because we're not trying to find anything specifically, we're just trying to find what that ratio would have to be. So on any given day, if you want to hear 4 times greater than the source frequency, you have to travel a certain fraction of the speed of sound, and that's what we're going to try and figure out. So in order to hear a greater frequency, we have to be approaching each other. So we'll write down our starting relationship for 2 objects emitting a sound and that are approaching. So that's plus the speed of the observer over the speed of sound minus the speed of the source. And just a quick little note, as with a lot of these questions, the speed of the observer is 0, so we don't have to work with that. Right, so a little substitution here so that we have less variables to work with. Observed frequency has to be 4 times the source frequency. And so that has to equal what the source frequency is, times speed of sound. Just make that a little clearer. Now remember, the observed frequency is 0. Excuse me, the observer's velocity is 0, so I'm not going to even write it on the top. I have this. There we go. It does not look like we're going to, it's like it's going to be very easy to get our answer out, but just kind of don't give up yet and don't stop playing it. But we'll work out a little easier than you might think. First thing, we get rid of those source frequencies. It doesn't matter what it is, our relationship is 4 times greater, so they divide out. Remember, when you divide out something, you're left with kind of a 1 in its place. So on the left, we have a 4. On the right is the speed of sound over the speed of sound minus the speed of the source. Cross multiply. Now it doesn't look like we're going to get our ratio out, but just kind of bear with me, watch the algebra. Cross multiply this to kind of get rid of that fraction. So over here now, it's going to be 4 times the speed of sound minus 4 times the speed of the source equals the speed of sound. Remember, when you cross multiply, everything in that denominator, if it's more than one term, has to multiply what's on the numerator on the other side. So it has to multiply the 4. So I'm just going to rewrite that down here a little clearer. 4 times the speed of sound minus 4 times the speed of the source has to equal the speed of sound. Now, sometimes in math, to get the answer you want, you have to make it happen. So we want a ratio of velocity of the source to the velocity of the sound. So I'm going to divide everything here by the speed of the sound. And the last one. So on the right, speed of sound divided by speed of sound divides out to be 1. On the left, those 2 speeds of sounds divide each other out. So you're just left with, on the left, a 4 minus 4 VS RC, speed of the source, with speed of sound. Remember, that's what we want. It's exactly what we wanted. I just have to rearrange this equation and leave my fraction by itself. Subtract the 4 from both sides. Divide both sides by the negative 4. So the velocity of the source over the velocity of sound equals negative 3 over negative 4, which simplifies to be positive 3 over 4. That's our answer. We're done. The question is asking us the ratio of the speed of a source to the speed of sound. It has to be 3/4. So if you want to hear a frequency 4 times higher, an object's got to get moving at 3/4 of whatever the speed of sound is.